So, good afternoon, Namaste.
Hello.
A very warm welcome to all participants joining us for session 3 of TTDD 2026 titled Security, Privacy and Trust in 6G. I am Chandrakanta Rathore along with Abhishek Ranjan, the session coordinators for today's session, and it's my pleasure to welcome you all. Before we begin, I would like to share a few important housekeeping announcements. These are also available in the chat window for your reference. All attendees will be kept on mute throughout the session by default. Kindly post your questions in the Q&A tab of the conference tool. This will be taken up during the Q&A session. Questions in the chat window will not be entertained. If you want to enlarge the presentation, please click on the expanding arrow icon at the top right of the presentation screen. The tool is configured for HD video. You may switch to LD in case you are facing bandwidth problems. Attendees may like to visit the exhibit booth of TSJSI in between the sessions to know more about our work. Attendees can use the lounge facility for networking. The lounge will remain open till the end of the conference. The conference sessions are being recorded and will be posted to the TTTD website in the next few days. Now, I would like to introduce our session convener, Mr. Vijay Madan. Mr. Madan is currently associated with TSTSI as advisor and mentor with special focus on standardization in services and solutions relating to evolving technologies and applications, vertical sector use cases, security and crypto, IoT, drone services, cloud computing, PPDR, future ICT enabling systems. Also with JWG's focus connected with 1M2M, 3GP, and ITUT. Welcome, Mr. Madan. May I now request you to kindly take the floor and introduce our session co-chairs. Over to you, sir.
Thank you very much, Chandrakanta. Welcome all the distinguished attendees, distinguished speakers, distinguished chairs to this very important session of security, privacy, and trust in 6G. As you will go along, you will see that we are discussing all aspects of end-to-end security, all planes and all verticals and all network from end to end. So this is very central to 6G, the security, because we are adding so many new features, both from the applications, use cases side, and as a part of dynamic network and so on. So it's my pleasure now to introduce our speakers, chairs. We have co-chairs today as Mr. Saurabh Khare, who serves as the chair of Security Working Group in TSDSI and heads the Nokia 3GPP SA3 security delegation. He has served as a rapporteur for numerous studies in both 3GPP SA3 and TSDSI, besides some other global forums, making substantial contributions to advancements in mobile network security, 5G and now 6G, and he's connected to other global forums also than 3GPP. We have the second distinguished co-chair from ERNET, Mr. Kirubakar. He's project manager ERNET India and working on advanced optical and quantum communication technologies. Holds a doctorate degree in wireless communication from IIT Kanchipuram, and after his post graduation in applied electronics from Anna University, where he has been a university rank holder, and we find both the coaches are rank holders in TSDSI contributions and other related activities. Thank you very much. I hand over to co-chairs to take the proceedings of the session today and to introduce the speakers, the context, and everything on 6G security, privacy, and trust. Thank you very much. Over to you, co-chairs. Saurabh, you would like to set the context today? Thank you. Mr. Saurabh? Would you be setting the
Am I
context today, please?
audible, sir?
Yes, Saurabh, yes.
Okay. Yeah. So this is thank you for again, sir. The point is security and privacy. To set the context, we should talk about what we are planning to do it here today, right? So we have a slide for that. Next slide, probably. But to start it, right, the security and privacy in 6G session will provide an overview of emerging challenges and ongoing standardization effort shaping future system where the security and privacy are expected to play a more fundamental and critical role than earlier generation. This is developed by AI native network services, expanded attack surfaces from distributed architecture, and need to support sensitive applications such as critical infrastructure, immersive services. This session will bring together the leading industry expert to present ongoing 6G security studies, including architecture evolution, AI native security, advanced privacy mechanism. This will also highlight complementary work done across SDO standards body and our national, national government policies. Participant will bring cross SDO perspective, even the national policies and securities, and we discuss discussions aimed at identifying gaps, fostering collaboration, shaping the unified global security vision. If you go to the next slide, please. So before I'll introduce the session, probably it's good to talk about what we are doing in TSDSI, because TSDSI is a forum where a lot of work has been done in security research. I'm also very happy to announce that whatever research we are doing in TSDSI, that is anchored in global SDOs. So you can see on right-hand side, the global SDO mapping, where I have highlighted the 3GPP SA3 studies. We have 3 studies ongoing, PQC, AEAD, and 6G SID. The IETF, which is mainly the PQC work is going on, and now agentic work is also getting started. Then we have HC ISG QKD group or ITUT SG17 group. So I have color coded these global SDOs to our left hand side TSDSI work. So the box is what you see here is the ongoing work. So I'll quickly talk about what work we are doing it. So first work is about PQC migration strategy for 5G and 6G. And you see this is where we define the migration strategy from the how PQC should be implemented in 5G and how should we do in 6G. And this work is definitely correlated with the 3GP PQC study, and that's why I put the boxes. And we put the color coding accordingly. Second item is about 5G and 6G beyond network security architecture to support multi-level end-to-end security, user plane security. So currently telecom security is hop by hop. But this study highlight the need and the support how we, if you want to start the end-to-end security, how this will be realized. Third is about AML-based security implementation in 6G wireless communication. So in air interface, we are currently using Snow, Zoox, and AES algorithms. Now this study highlight the and took the base as Zoox and try to enhance the Fulgur based on AI ML. We try to enhance the algorithms. This is pure crypto study. Now, second is about zero trust, which we are exploring in C2X communication. Next is about seal architecture. Seal is something which is defined in 3GPP, where application layer authentication authorization is defined. So we are trying to explore some drone or AML use cases there. Then the security of AML enabler or security of enabler for 6G system. So there is talks about PQC, AIML, different privacy mechanisms over in the previous generation drawbacks. And this definitely have a relevance with 3GP as well. And couple of more study, if you can see, QLess quantum safe lightweight secure sessions, and we have QKD hardware using SDN. So these are some work going on IETF, some work is going on in HC. So that's the overall picture what we are doing in TSDSI and corresponding global map. And Chandrakanta, can you click? Yeah. So based on this theme of work, what we are doing in 3GPP, we have selected this theme of today's session, TTDD, where we categorize things into 3 buckets. First is definitely 3GP telecom security. We define the telecom security. If you click next, then we have ITF, which is about internet security, and last is national security, right? So based on these three pillars, we have selected our keynote speaker and panel discussions, which is surrounding this. If you go to the next slide, please. Yeah, so this is our agenda. We have started welcome remark, then we have first keynote speaker, Mr. Rajvel. He's so I'll introduce him. Then we second keynote speaker, Mr. Tiru. Third is Mr. Nagendranath ji. Then I'll hand over to Kruvakaran ji to start the panel discussion. Panel discussion, we have Anupam ji, Saujanya, Manjesh ji, Subramanian ji. Then we conclude it. So let's start with the first part where we will start the keynote speaker. Chandrakanta, can you go to the next? Yeah. So first keynote speaker, I was explaining there are three pillars, right? First is 3GPPs, and very known face, Mr. Rajvel, is from 3GPP because Mr. Rajvel is a telecommunication network security expert with nearly 20 years of experience in mobile communication, security architecture, and global standards. And he's also a SA3 chair. So welcome, Mr. Rajvel. Maybe you can start. Next.
Thank you, Saurabh. Thanks a lot for the introduction. Hello, all. Yeah, I'm going to have the snapshot of the 3GPP 6G, particularly security aspect standards, how far we are, and how much we have done, and what is the future plan. So going to the next slide. Okay. On the introduction, yes, I think Saurabh already touched upon that. We have three study items currently going on. That is for the release 20. First one is the 6G study itself, and we have started in October 2025. The current status is only 30% because we heavily depend on the other working groups to make significant progress to define the security aspect for the concluded or the ongoing work in the other working groups. Based on that, we have agreed on 10 security areas in our TR, and we are prioritizing RAN aspect because the RAN aspect is needed for the checkpoint, that is the RAN SA3 checkpoints. Basically, the checkpoint is to facilitate the early integration of security requirements into the RAN architecture, which is the main utmost important because we want the day one to have the complete security aspect, and we need to have the concept of security by design. So we have checkpoints in order to have the collaboration with the RAN working groups to integrate the security requirements. And we started the work with the assumption for at least for the...
The speech is not clear, it's breaking. I don't know if it's the case for everybody.
Sir, at least I can hear him well.
Okay. I will
clearly, but here his is not coming out. Okay. Just
I will speak aloud. Let me check. Yeah.
it was breaking.
So the assumption we started with the 6G, at least for the asymmetric requirement, is that 5G security requirements will be taken as the baseline for the 6G RAN aspects also. So with that, we started the work. And the next one is the support for AAD algorithms. We considered this as a separate seat because it is entirely SA3 seeded work, or it entirely belongs to the SA3. And for the conclusions of AAD, still we are under discussion. Coming to the migration to PQC, which is also specified by the Saurabh, we made a very good progress, I can tell. And we started this as a separate seat. Why separate seat? In the sense we like to have the G agnostic study on PQC. And we have the main purpose of the SID is to update the profiles for protocols defined by other SDOs, but which are used by 3GPP and also 3GPP defined thing. Next one is the mechanism for transiting to the PQC. That is one of the aspects we need to consider. Even if it is a 5G or 6G, we need to adopt, if we go for the PQC, how the system is going to integrate or support it. So PQC study is almost concluded and the bid for 5G is approved in September. I will just detail all these points in detail in the coming slides. Going to the next slide, please. I think for time being, I will just off the video so that I think might be good to have the voice. Okay, coming to the release 26G study item timeline. As I said that we are progressing here. We started the work in September last year, and we are making the progress, and our deadline is in June 2027 because we need to align with the RAN 2 work also. So we have extended till RAN 2 things. But if you see the stage 3, it goes beyond, and they have the deadline as September 2027. Next slide, please. On the release 21, this is the timeline agreed in the last SA plenary, that is the September plenary. And here it is clear that the stage 1 freeze date will be the March 2027, and stage 2 will freeze at June 2028, and stage 3 freeze will be further. As you know that usually we will do the parallel, so the parallel or overlapping of the release at the end, that is release 20 is about to end, then we will, before only we will start accepting the packages or start discussing the packages for release 21. But the start date is not defined yet. So, but there will be a mid of 2027 or at least the quarter 3 of 2027, people will start discussing on the normative bid for 6G. Next slide, please. Okay, I will spend some time on this, and this is the 6G study and what we have done till now. As I indicated, we have agreed and captured the 10 security areas in the TR for further consideration, going one after one in anti-clockwise. First one is the security architecture, which defines the security domains, trust anchors, security functions, and the key hierarchy, which is going to be the whole baseline for our work. The next one is the RAN security, which we given priority. It covers protection of the radio protocols, interfaces, and procedures between the UE and the access network, including the MAC-C. Currently, the lower layer, when I tell lower layer, it is the below PDCP, is not protected. So in this study, we are considering the lower layer protection also. And this area includes the mobility security also. Focus area is completely to prevent tracking, tampering, and reply of the control plane messages over the air. The next one is the UE to core network security, which secures the NAS signaling, key hierarchy defined for the entire system, and also the identifier privacy between the UE and the core network. This security area also covers interworking with the legacy systems and secure parameters transfer between the home network and the UE. The next one is the security for core network, interconnect, and roaming, which is one of the important topic. Basically, it is the protection or the authentication and authorization between the network functions and secures the interconnect, roaming, and the SBA, that is the token-based communication for authorization, is covered in this area. It also includes the trust anchor distribution across domains. The next one is the subscription authentication and authorization. Covers the primary authentication and key agreement between the UE and the network across 3GPP and non-3GPP access network also. It also addresses the subscriber identity privacy and slice-specific authentication. The next one is the exposure security, addresses the security and privacy aspect of 3GPP network exposure mechanisms, ensures exposed network capabilities or data are protected from the misuse. That is the main objective of exposure security. The next one is the data collection for secure monitoring. I think it is already work started in 5G, but this is going to be more on the governance of secure parameter collection of relevant data from CN, OMA, and UE to network communication. And it is going to feed an out of scope of 3GPP network monitoring systems. We are not going to define what is the secure monitoring function is. This data is for the monitoring functions. Next one is the UEA agent security, covers authentication and authorization of UE agents running on the UE, which is an emerging area, and SA3 is going to wait for a significant progress in the other working group, especially SA2. The next one is the data framework security. It addresses the authentication and authorization of 6G data framework, coordination with SA2 and RAN5 is very much needed because a parallel work is already done or going on with SA2 and SA5. The next one is the sensing security and privacy. It was included in the last meeting. It is to protect the sensing service authorization, sensing data, and also operation between the sensing function and entities in the integrated sensing and communication. Basically, it is going to be built on the already work done for the 5G sensing, and baseline 33777 is to be considered. So this is the current security areas under consideration, but it is not limited. Going forward, if required, we may add more, and we are going to start focusing on other areas, not only RAN security going forward. The next slide, please. We had a very good checkpoint in June where we exchanged the status with each other, that is with RAN2. So going forward, we have decided that we are going to have a December checkpoints on the AS security. I think it is of interest to all the companies to know what will be the plan for the December SA and SA3 and RAN2 on the checkpoints. We have agreed that 3 checkpoints to be considered. One is the MAC CE security. Basically, SA3 need to provide the guidance and the requirement based on the risk analysis and some possible security solution design directions. For example, whether it is done at the PTCP or at the RRC, like so, on the aspect to protect the MAC CE, so that there will be an closer interaction with RAN2 is required. With that input, RAN2 continues discussing how to include the requirements received from SA3, and it is going to have the protocol design with the RAN plenary guidance. On the second point, that is MAC I size, currently SA3 is discussing, but we need to make a conclusion on the MAC I size, and also we need to clearly specify whether it is a fixed for all packets or dynamic. This is needed for RAN to design the user plane header accordingly. And we already received, SA3 already received RAN2 LS, indicating that their preference is to have a constant MAC-I length, not a variable one. On the checkpoint 3, support for algorithms for AS security. SA3 to conclude the support, whether it is 128-bit algorithms or 256-bit algorithms. This is basically needed for the hardware change assessment, because if it is 128, if the 6G starts with 128-bit, which is also a post-quantum secure algorithm, If that is the case, then the hardware change may not be required immediately. But if we go for 256-bit algorithms, from day one, there is a need for an security accelerators in the G-Node B. So it is of interest for RAND to know what is the decision in SA3. And they asked us to provide SA3 to provide a progress report. If there is some conclusion is made early, then it is easy for them to decide early. So this is the checkpoint we are going to have in December. Next slide, please. Okay, the next slide is the AEAD, that is authenticated encryption with associated data. Basically, it is a cryptographic mode that combines the encryption and integrity protection in a single operation. And the deciphering will happen, and also it at the same time it validates whether the message is tampered or not, whether it is intentionally or unintentionally. So this is the mode what SA3 is interested to study. Coming to the conclusions, we captured the conclusion in 33771. In the conclusion on the algorithm selection and AAD algorithm interface, it is not concluded yet. When I tell interface, it is the input parameters, how it is going to fetch the input parameters like so. It is not yet decided, and conclusions are going to happen in next upcoming meeting, that is the August meeting. And the conclusion on the AED keys, it is already indicated that we are going to use the 5G as the baseline, and we are going to define the new FC values for the 6G system, and also algorithm identifier values also are also to be defined during the normative work. This is on the AEAD. Next slide, please. Okay, coming to the post-quantum cryptography, yes, I given the introduction, that is G agnostic. We started with G agnostic. Before start of the study itself, we have gathered the 3GPP specification usage of the cryptographic algorithms in 33938. With that, we started the study, and we are able to conclude most of them. And we concluded the following things. It has two things. One is that we are going to work on the, or whatever 3GPP is using the other SDO defined protocols, we need to identify and watch for their updates. And if there is anything, then we are going to include that particular PQC in our profile. And mainly the protocols we use, or 3GPP use, is IKV2, DTLS, PKI certificates, and also the application layer costs, and those protocols are used. And with that, we are closely watching with the IETF progress. Once it is, we already identified these are all the particular RFCs to be adopted, and also we are waiting for the drafts to get RFC status. Once it is done, then the profile will be included in the normative work. On the protocols defined by 3GPP and migration to PQC, Mike Isaki, SA3 decided that not to address this in the present document, but it can be considered in a different study, for example, in mission critical, where Mike Isaki is used most. The next one is the Suki calculation. In the last meeting, we made a conclusion that asymmetric schemes recommended for normative work. Basically, we have agreed on two groups. That is, Group A is the standalone PQC scheme, and also Group B hybrid is also being accepted, and it will be discussed in the upcoming meeting, and a decision or conclusion to be made. So this is the status of PQC. Next slide, please. Okay, it was proposed in the last meeting to have a bid, and the bid is to include the following work task, and the bid is also approved. Basically, it is for 5G itself. That is, SA3 decided to include certain PQC aspect in 5G itself. That is the introduction of PQC key encapsulation algorithm in the 3GPP cryptographic profiles for DTLS 1.3 and IKEv2. And also we introduced to have the work task on PQC algorithms in the certificate profile for vendor credentials. That is the impacted TS is TS3310. Basically, it includes the vendor root certificate, vendor CA, and also base station certificates. And also, it has been decided that we need to slowly phase out TLS 1.2. We cannot do it immediately. It should be done in stages. So we are going to have the normative work on how to phase out the TLS 1.2. So this is the current agreed with and the status of PQC. I think that's all from my side. Next slide, please. Yeah. So Saurabh,
Thank,
do I have some
yeah,
time for question
thank
and
you.
answer or yeah?
Yeah, thanks a lot, Rajbir. Thanks a lot again for a very nice presentation covering a whole 3G perspective. I know it's a very short time to cover the whole thing, but you nicely summarize the whole work, what we do in 3GPP in security into a 15 minutes. We are actually overshooting the time, but we can take one question. So there's a question which says, will PQC adoption require a new UICC eSIM hardware capabilities, or can existing deployments support PQC support through software upgrade?
Uh, it really depends on the deployment because we have both the functions or functions supported. Either UAICC can do it or ME can do it. If the operator does not want to change the UACC, then he can ask the mobile vendors to have the software update. Or if he is clear that he need to provide an UACC which can have the PQC support, then it can be a next version of UACC is also possible.
Thank you, Rajwant.
Thank you.
Yeah, I guess we have only one question here, but thank you again, Rajwant. Probably
Thanks a lot.
you,
Thank you everyone for the opportunity. Thank you.
thank you, Rajwant. So nicely, Mr. Rajwal has summarized what work has been done. So this is a three pillar initially we talk about 3GPP, ITF, and national security. Now we are going to the next pillar. Next pillar is ITF. And for that, I would like to introduce our next speaker, Mr. Thiru. Can you go to the next slide? Yeah. Thiru is working with my colleagues, so I'm happy to, very happy that he's presenting here. Thiru Thiru leads the security and privacy standardization effort and security research at Nokia. He is a principal research lead with 25 years of experience in delivering and cutting edge solutions in network security and IoT endpoint protection. So, Thiru, next slide, probably can start. Thank you.
Hey, thanks, Saurav, for the introduction. And I think the presentation from Rajwell gives the context on why the work happening in ITF is relevant to 3GPP and the broader internet security, right? I can move the slides, or like, do you have to? Okay, thanks. Yeah, so as you can see, right, from Rajwell's explanation, right, 3GPP security pretty much uses IETF security protocols, other than few exceptions like Suki encryption and few others. So nearly every 5G security interface that I have studied, right, pretty much normatively references an IETF security RFC. There are several protocols, right? I didn't want to go into all of them, but I've listed at least the 6 protocols that I felt are quite relevant, right, to 3GPP, right. One is TTLS 1.2 and 1.3, right? And IETF has, just to give some context, right? IETF has obsoleted 1.2. So any enhancement that's going to happen is going to happen only on TLS or DTLS 1.3. And IQV2. IQV2 is pretty much used by 3GPP and across the internet for basically privacy. If some endpoint wants to tunnel the traffic, and enterprises always use that for DMVPN and other kind of configurations. SD-WAN IPsec is a quite popular deployment as well. And then EAP, right? EAP is probably the the most widely deployed authentication, network level authentication that is deployed today. And 3GPP uses EPK, and then the OAuth basically, right? OAuth is the framework that IETF has defined several years back. It's used by 3GPP and by the entire internet ecosystem for authorizing someone to access a particular resource. And then the entire suite of PKI, public key infrastructure, which includes X.5.net certificates, certificate management protocols for enrolling to get certificates, managing certificates, revoking certificates. And the last piece is basically JSON object signing and JSON web encryption, which is predominantly used by OAuth and several other uh, uh, several other protocols predominantly use JOSE and JWE for object level encryption and basically uh, providing signature to attributes that are going to be conveyed for end-to-end security. Next slide. Yeah. So I've just listed all these IETF working groups. So IETF pretty much works in the concept of working groups. So every protocol, right, is developed in a specific working group. And I've listed the working groups along with the 3GPP touch points. I'm not going to go over all of them, but the ones that I did not talk in the previous slide are SEAT. SEAT is a new working group that got formed, which basically talks about attesting evidence, hardware evidence carried in DTLS handshake, which basically uh, allows you not only to validate your peer's identity, but also to prove that, hey, your peer is running on a legitimate platform, it's using a legitimate firmware, it's using a good reference software, and it's storing all its private keys securely. So you'll get all that attestation information from hardware. So then you can decide whether you want to communicate with that peer or not. So this is some new work that has kickstarted and is going pretty well within IETF, and I'm hoping 3GPP will pick it up. Beyond that, there is Whimsy working group. Whimsy working group also started a couple of years back, which talks about workload identities across clouds and platforms. This working group was kickstarted by cloud vendors, basically because they have network functions, and they wanted to make sure how do these workloads talk across domains, how do you identify these workloads, how do you provide end-to-end encryption and data origination of request, especially when you're traversing multiple workloads. So all those issues are being dealt in the Whimsy working group. And Acme is another variant of CMP v3, right? And there's some interest, at least I heard in 3GPP, that uh, some of the vendors want Acme to be deployed because of its popularity among web PKI. And then the last one is AA Proto. As many of you may be aware, right, there's a lot of interest in 3GPP to leverage agentic protocols for various use cases. And ITF is now going to create these protocols and frameworks and discovery mechanisms. So it can be used by 3GPP and other network deployments. Next slide. Yeah, so I'll talk about the post-quantum cryptography. That's one of the major work that is happening at IETF, right? And IETF has analyzed both the symmetric cryptography. If you can click a couple of more times, yeah, on this slide itself, yeah. So if you see, right, IETF has analyzed both the symmetric cryptographic and asymmetric cryptography. With symmetric cryptography, with the Grover's algorithm could break symmetric cryptography, but practically it seems impossible to break that even if you're using AES 128. So IETF has decided and published RFCs as well, claiming that we will not be obsoleting AES 128 in the near future, and it may be obsoleted in the future, but IETF protocols, especially IQ2, TLS, SSH, they will continue to allow and support AES 128. The more impact is on asymmetric cryptography, right? And they will all be broken by Shor's algorithm once you have a cryptographically relevant quantum computer, and that's where we are driving a lot of specifications at IETF to evolve these protocols to adapt and leverage PQC algorithms. Next slide. Yeah. So a couple of interesting solutions that came out of this exercise was that the protocols were never built basically to leverage PQC algorithms because of the chem encapsulations they have, larger signatures, right? How do you deal with that with large public keys, large ciphertexts, right? So ITF has spent a lot of cycles in redesigning many of the protocols, right? Like IQ2, TLS, and all of that, and discussions are still happening, right? And the one scheme that came out of the entire discussion that happened in the last couple of years is that ITF is pushing for all hybrid schemes in the sense that it would mean that we recommend protocols to use both traditional and PQ algorithms together, right? So that you can get the security from both the features, right? For instance, if you're using it in TLS, use traditional, get the shared secret. You use PQ, get a shared secret. You hash them up together, and you get the final secret. So the advantage of that is, right, even if let's say you're deploying a new MLChem algorithm and there's a bug in that or vulnerability in that, you're still protected by traditional, right? And that's the reason why hybrid solution has kicked off, and it has seen wide scale deployment across the internet, right? Not just browsers, content providers, several products of Apple, Cloudflare, and other vendors have already deployed the TLS based hybrid solution today. And one thing that came out of this entire design that we have taken up is to redesign these protocols. So whenever new PQC algorithms do come, and we anticipate them to come in another few more years, ITF has just standardized three of them right now, which is MLChem, SLHDSA, and MLDSA. But in future we will see a lot more, right? So the whole idea is these protocols are now designed with lot more agility, in the sense that you could incorporate new PQC algorithms without having to redesign these protocols. But then systems now will also have to be uh, upgraded in a way that they have inbuilt cryptographic agility, so that with minimum disruption they could upgrade and embrace new PQC algorithms. Next slide. Right. Um, so as you can see, NIST has standardized several PQC algorithms, and NIST is going to continue evolving them, right? And ITF is taken them and has started developing protocols. The key exchange one, which is the most predominant attack that's already happening because someone is wiretapping your traffic and wants to listen to it after a quantum computer comes, is the one which has stable RFCs now, and open source implementations, OpenSSL, and several other open source cryptographic libraries already support key exchange. So that's pretty much in a stable state for 3GPP and other SDOs to pick up. The work happening in Signature is ongoing, right? It's making good progress, and some of them are in stable state, but there's a lot more work to happen. And I'm hoping by the end of 2026 it will reach a good stable state that 3GPP can pick it and use it, right? So as my previous presenter was mentioning, that 3GPP is carrying a separate study on that, and they're pretty much leveraging the protocols that have been enhanced in ITF. Next slide, please. Right. So the most important attack, right, harvest node decrypt now later, right, is being discussed in TLS, IPsec, and PKIP working groups, and the standards for that are already ready, and the industry has started deploying that, and I think 3GPP is also making good progress on leveraging these specs, which are quite mature, so that network vendors and operators can start deploying these new standards. Next slide. Right. I'm going to talk about some other new work that 3GPP has not picked, right? So this is something that we recently started, like around 3 to 4 months back. So this is a newly created charter in the security area, which talks about attestation, right? It talks about hardware attestation. Uh, Today, when two peers talk to each other, you just validate the identity, but you don't know whether the peer is running on a platform which is legitimate or not, whether it's compromised or not. That sort of evidence now TLS will be extended to provide. So this will complement the existing TLS authentication, and there is a lot of interest from the confidential computing consortium and cloud providers like Google, AWS, right, who are offering cloud computing infrastructure to run your VMs within trusted execution environments, to isolate them even from the cloud provider, right? For them, this really matters, because today there is no standard mechanism to exchange the peers attestation evidence to validate whether the peer has been compromised or not. And irrespective of the identity, this plays a very critical role, even for AI agents, right? When you want to share personal data, want these AI agents to execute sensitive and mission critical tasks, you want to validate that these agents are indeed not being run on compromised platforms. So this work is playing a lot of interest at IETF and across the internet, and I see a lot of progress being made there, and I'm hoping 3GPP will pick that in the near future. Next slide, please. Right. So beyond that work, right? I mean, OAuth is something like, I know 3GPP uses OAuth, right? But OAuth is going through a lot of changes, right? ITF has picked now OAuth 2.1, which basically obsoletes some of the features that were there in OAuth 2.0 and adds a lot more functionalities. I'm pretty sure 3GPP would be interested in that. We have come up with a security best practices on what to use in OAuth and what not to use in OAuth, because OAuth has been there for more than a decade now, right? And then we are introducing a lot of constraints, basically, right? A lot of cryptographic proofs within OAuth itself, to make sure that somebody doesn't misuse the token that is provided, right? I mean, today there is no such cryptographic binding in OAuth. They're simple bearer tokens. Now you could bind these OAuth tokens to your TLS handshake, to the public keys that is provided to your client, and you can basically restrict these tokens to reduce privileges, give additional permissions or one-time tokens based on based on new authorizations that could be provided. And this is going to be a lot more dynamic, unlike at beginning of OAuth, you just ask for an OAuth token, you get a token, and you use that for with unrestricted access based on the privileges. So uh, the granular permissions is the way that OAuth is going towards, especially with delegated delegation across AI agents is one of the use cases where there's a lot of discussion happening on how do you make sure these tokens don't cause escalated privileges attack, right? So there's a lot of interesting work happening in OAuth. If somebody is interested in it, please subscribe to the OAuth working group. Next slide, please. Right. The other work that I was talking about is WIMSI, workload identity for cloud native workload. So this work is pretty much of interest to all the cloud providers, as they want to leverage this work for ensuring workloads authenticate each other. Workloads can basically ensure that even across different workloads, when your requests are traversing through, you would identify who the caller is, and basically assign these requests in a way that the eventual workload which is executing this task knows who the caller is, and basically it also is working on concepts like um, end-to-end data origin authentication by providing signatures into these requests and responses as well, right? So this I believe is quite an interesting work uh, for any cloud deployment, and 3GPP is also has cloud native workloads, and 3GPP can leverage some of this work. Next slide. Right, and I talked about EAP as well, right? And EAP, there are two pieces to EAP, basically EAP AKA, which is prime, which is driven at IETF, and the EAP TLS, which is I think used by the private networks in for mutual authentication, right? All these specs are now getting enhanced. For instance, IETF has recently defined enhanced EAP AKA prime and EPK with forward secrecy. EAP TLS is now being standardized to use TLS 1.3, and EAP is also being enhanced, right, to adapt and leverage PQC algorithms. Next slide. Right. I just briefly talked about ACME. Right. ACME is probably a sibling of CMP, and if an operator is interested in that, CMP not doesn't want to use CMP for their own reasons, they could consider deploying ACME, and ACME is actually being quite actively being developed at IETF. So IETF is pursuing both CMP and ACME for various deployments, two different protocols for people to pick and choose. I know 3GPP predominantly uses CMP, but for someone who wants to use it optionally, can also evaluate this. Next slide. Right. So I talked about AI Proto briefly, right? AI Proto is going to be a new working group that's going to be created, where the predominant work is going to happen on. We recently published documents on the use cases and requirements on why IETF should take it up, what would be the architecture for this AI protocol work, how will agents talk to agents, how will agents communicate with tools, how will agent authentication and authorization happen, and how will agents be discovered, right? So this is going to be a very interesting work that IETF is going to kickstart, and we're going to analyze already MCP and A2A, which is already there, and develop protocols. Because if you look at somebody looks at A2A and MCP, they're pretty much leveraging what is defined at IETF, right? They're using TLS, they are using HTTP 2.0, and basically JSON, right, and OAuth and other security frameworks. So IETF is the right place to build this so that it could be deployed for internet scale applications. Next slide. Yeah, there are several other working groups. I'm not going to go over all of them, basically, right? There is interesting work happening in supply chain transparency and secure software updates, basically, to make sure your firmware updates are secure. And there's a lot of work happening in privacy aspect using concepts like OHA and mask, basically, to provide privacy to the end users, basically masking the end user identity from the content providers, right? And each has its own different properties. IPsec is also being enhanced to basically cover various aspects like group performance, group keying and performance, and other fragmentation work. Next slide. Yeah, so these are the four fundamental areas where I see PQC identity, automation, and AI agent works, which I believe will be of lot of interest in the coming years for 3GPP to book and leverage. Thank you.
Thanks a lot, Thiru. Thanks a lot for summarizing the whole IETF work into 15 minutes, 20 minutes time. I do understand there are a lot of things to talk about, but you nicely summarized them very well. I don't see a questions here. That's why if there's no questions, we can move to for summarizing this work and creating the relevance for the 3GPP and the Thank you.
Hey,
Yeah.
thanks, everyone.
If there's no questions, we can move to the next. Thank you, Thiru.
Yeah.
Okay, the next speaker is as I was talking about initially, we have three pillars: 3GPP, defined telecom security, IETF, and the national security, which is the most important part. I'm very happy to announce Mr. Narendra Nathji is here with us. So Narendra Nathji is working as a Joint Secretary, National Security Council, Secretariat with responsibilities for ensuring cybersecurity by different entities of India in government, public and private sector. Narendra Nathji, floor is yours. You can start. Thank you. Narendra Nathji?
ठीक है. I have to unmute myself. Okay. Thanks.
Yes, sir.
Okay. Thank you. So are you able to hear me?
Yes, sir. We can hear you.
Okay, thank you. So it was very enlightening listening to my two earlier speakers on 3GPP and IETF work that's happening. I'm not
Sir,
privileged to
sorry to interrupt you. Could you please turn on your video?
turn on the video. Okay. Yeah, maybe you're able to see me?
Yes, sir.
Yeah, thank you. Yeah, so I was saying that privileged to hear my earlier speakers on 3GPP and IETF. I don't have the occasion to really get into in depth of what's happening, though I know that some work's happening. Thank you for those insights. Coming from the national security perspective, end-to-end security that's been given to me, telecom is one of the sectors which has been declared as a critical information infrastructure. Okay, and based on that, there are a lot of activities that are from the NCIPC and from our office. We ask the sectors to take care of. So specifically in the telecom sector, just taking a minute, we had come up with one of the things, and especially, when the 5G was coming and a lot of IoT deployments happened, we thought that security in telecom sector has to really be ramped up. And there were certain initiatives that have taken place. One is regarding that NSDTS, National Security Directive on the telecom sector, which most of you might be aware of, which was done in December 2020. It's kicking off in June 2021 for taking care of the supply chain security, especially regarding from where the different components of network were coming from. And then we also have the Department of Telecom, looking at coming up with what is called the ITSAS, Indian Telecommunication Security Assurance Requirements, which looks at the technical aspects of what should be the security, features that should be built into products to make the network element secure. And of course, in addition to these two, we also have requirements for network security, where we talk in terms of having audits. From where we are perched, we see that there have been breaches in the telecom networks, and that is a cause for concern. So whenever you talk in terms of these coming up with new technological progress and 6G coming along, one of the things that comes to mind is how do you address the issues that are currently exercising us, both in terms of how the networks function and also how the services are delivered. We talk of APTs that are there, advanced persistent threats that are resident in the networks, and that they don't get detected, and also result in data exfiltration, or also sometimes in bringing down network elements so that service disruption happens. So one question that comes to mind is there a way for us to design networks that you can detect whenever there is an infiltration of the network through an APT actor happens, and that could be detected by the way we architect the network and the security features are built in. What we talk of secure by design, and that is something I find in the 6G. One of the principles based on which it is happening is to have secure by design. So that is one part that we talk about. So both when you talk of secure by design, we're looking at secure by design at the equipment level, secure by design at where the network is architected, and we also look at how secure by design, we say how's the traffic handled so that we don't have these issues of traffic diversion that could be taking place. We have separate protocols that are there for the mobile networks and separate protocols that are for the internet network. Is there a possibility, and in the internet, with the BGP diversions that happen, traffic diversion, is there a way that we converge both of the protocols in them to see that this particular aspect does not take place? That's one. The second is, earlier we were on the premise that and all telecom networks are interconnected, and the premise was that the other operator is a trusted operator. And we have issues with signaling 7 also, where when we have a rogue operator from any of the adversarial countries, there are possibilities that your network itself could be compromised. So how do we build in the security features in that, so that even though our networks are interconnected across borders, if we have a rogue network who try to penetrate and then infiltrate a network or bring in a malicious activity on there, what are the security features that should be built in to see that that doesn't happen? So that is another aspect, I think, that as a standardization body we should be looking at that and seeing how do I take care of that, along with what the cases of spoofing that keep on happening. How do we prevent spoofing? So this is one work item that has been there for quite some time, and that is requires to be addressed. Looking at the different elements that are there, when you look at the endpoints part, there are there are trusted transactions, there are untrusted transactions that happen. How do I separate those trusted and untrusted transactions on my device so that I can continue to do, for example, financial transactions, while I also access broader internet and all, where there could be some problems with the level of trust that is there. So how do I design the endpoints that is to see that this both of them happen so that fraud doesn't happen even though you use the device for multiple types of transactions. Then one of the issues that happens is that fallback, to earlier technology, that the device falls back, and then the security features there are not as robust as the newer technology. So how do I take care of fallback? One of the things I was seeing is that 6G is going to be separate. It's not like it's going to stand up to it's a standalone technology and network. That is what's being looked at in the current. I think that's a good one. But I think this is one thing that you should look at, that how do I look at the fallback issues that were there earlier. And then also, because 6G would be looking at a lot of machine-to-machine communication and device IoT device communication that's happening, the secure updates and upgrades that should be happening, and what is the mechanism for doing that on a large-scale basis. I think these are some of the things that require at the endpoint level that comes to mind. Then when we come to law enforcement, lawful interception is one part that we keep talking about. The one of the things that law enforcement looks at currently is, for example, sometimes some of the services required to be disabled in certain geographical regions. How do I do that? Is there a granularity that can be achieved so that the general population continues to avail services while certain services could be disabled, or certain services could be disabled to a certain section of the population, especially because of law enforcement requirements that are there? That is one design requirement that is there, and that should be considered. The other is regarding malicious calls, which happen. You find there's a lot of malicious calls. Is there some intelligence that can be built into the network so that these malicious calls could be detected at scale, and then preemptive action taken so that people are not defrauded? So this is another thing that that is currently a problem statement that we have. And how do you address that when you're talking in terms of deployment of new technologies? Is there a possibility to blacklist and whitelist certain features and certain customers? Okay, that is one. The other is the resilience part. I mean, telecom networks compared to other networks are very resilient. There's a lot of redundancy that's built into it. But I think resilience should also be looked in afresh. And the resilience for design is something that I found that when I was going through the site, that is also one of the core principles based on which the current standardization work is happening. So that's one. From our perspective, it's important that that is taken care of. Then we come down to this in the security part. When you look at the security part, we have the SOC operations. Then you look at monitoring of networks for security incidents and all of that. You also look at auditing. These are two separate functions that we talk about. And even now, for example, you'll find that some of the operators, they don't have audit function, and then specific audit function is to be built. And there are a lot of breaches that keep happening and all of that because audit is not happening. The auditing being part of the network is an important part, because when you design and install networks, and then there are standards-based networks that are put in place, especially in the telecommunication sector, if audit becomes a part of the network design, it becomes very easy across operators, irrespective of the maturity of the operator, that the networks get audited and then they are secure. So that is one part, that audit as a function should be part of the network architecture, along with the data collection for security monitoring is something that was mentioned by one of the speakers earlier, and that's what he said it is one of the things. He talked of EU agent security, data security, and sensing security. It's very important. So data collection for security monitoring, it's very important. I think that's where I think SOC operations part becomes part of the network, because that's an integral, that SOC operations is an integral part of network function. And I think that also being part of, when you talk in terms of 6G, is something that we will be looking from our side. We'll be looking that it becomes part of the data collection for security monitoring is an important part. I think that will be taken care of. Then we come to some of the statements that were made that it will be AI native 6G. Good. And then because with current developments that are happening in AI, we've been asking people to look at using AI for security. Okay, and also we also have these concerns regarding the security area. And I think both of the things are being looked at as per the literature that I've gone through. The aspect of the AI native is that you're using it for, let's say, enhancing the optimization of that and looking at those aspects. But I think the problems of AI systems being of the drift that is there, of the poisoning or data poisoning that happens, these are things that I think should be part of the design philosophy so that they could be detected. Because I have a feeling that if we incorporate large scale AI into the networks and we don't have the expertise built across board, then we would be actually landing up with bigger problems. So I think when the design part comes about and you put that into standards, I think these are some things. How do I monitor an AI to see that it is performing as per what it was decided it was supposed to perform with, is I think part of the standardization activity that should happen. And also that it also becomes part of the SOC operations part of the year that is there. Then coming to the PQC part, there are a lot of crypto, and then we had a good presentation regarding the IET of the work that's happening and regarding the PQC transition. One of the statements that was made was that they are proposing to retain AES 128 because in the symmetric key that AES 128 seems to be okay. But when you're transitioning to new technology and when you're talking of IMT 2030, would it not be good that I'm not talking of current systems which are there, but when you're talking in terms of 60 systems that are going to be deployed, why do you want to retain AES 128 when you could go for AES 256 at this particular point of time? So that systems of 60 which are going to be deployed after 2030 are all having AES 256. It would be difficult, if you retain AES 128 now and then later on decide that we have to go to AES 256. There might be some re-engineering that would be required and some equipment replacement that might be required. I'm not very sure that is the case, but that might be required. So I think it's better to reconsider that for the IMT 2030, we should be looking at having AES 256 instead of retaining AES 128. Okay, and in the PQC transition also, and when we've been talking of PQC transition from our National Security Council Secretariat also, along with many of the critical infrastructure, how do we transition to that? And we have also kept some timelines for having to do that. So in that, one of the things we talked about is crypto agility, in the sense that because, and then you were talking about hybrid PQC in that respect. The crypto agility is something maybe it should be part of the standards activity in the sense that IMT 2030 systems that come in should be crypto agile per se. And then the other thing that should be there is regarding the CBOM part. And then I saw in the presentation that ORAN, the ORAN part, I think they have done a complete inventory of the crypto assets. Crypto inventory has been done. That's a good part. But is it possible that in the system architecture that is there, the CBOM becomes a part of onboarding of cryptographic assets? In the sense it becomes part of the system design. That whenever I introduce a cryptographic asset into it, it becomes part of the CBOM. So I don't go in for a separate activity to prepare a CBOM for a network. So that plus also this SBOM, because SBOM is also something that we are talking about. The network, because telecom networks are highly regulated networks, standardized networks. If these two features, automatic CBOM and automatic SBOM creation, if they become part of that, then it will become very easy to monitor. Especially for example, what's the software versions that are there, and what are the updates that are to take place. How do we monitor that? Which are currently very big challenges that become part of the network. It becomes very easy. So I think these two are something that we look that if in the standardization activity that happens, that CBOM and SBOM become part of the network architecture, and they come up automatically. So these are some of the things that I thought I wanted to bring to your knowledge. The other is, of course, you talked about data handling and sharing. There's a lot of network data that comes around, and there's a lot of there's a sharing also for public good that's required. That I think is being taken care of broadly, and I think there's a good understanding of that. Finally, I would like to conclude by saying that release 20 is a steady phase of 6G, and a lot of these requirements are being firmed up. What we would like is that larger Indian participation with a good understanding of our Indian requirements is there in the SA group, SA3 group, so that whatever I've talked about and from your own understanding of what is required is taken care of there. I would further require that the DOT along the TEC has a some sort of a consultation among the different stakeholders here, along with in the security establishment also, to firm up those requirements that are currently not being addressed by our existing networks, the current problem statements that are exercising our minds, so that it consolidated and feed into the standardization activity that happens. So thank you very much for this opportunity to talk to all of you.
Thanks a lot, sir. Thanks a lot. This is a very nice presentation, and you nicely summarize the national requirements and where we can improve and where we can collaborate. I guess some collaboration we did it in the TSDSI forums where we have severe studies on PQC and all, where duty colleagues also involved, and we had a good collaboration there. But I guess this definitely require more improvements and more work. But thanks a lot for good suggestions.
Yeah, thank you.
Okay, from question. Thank you, sir. I don't see a questions here. Probably we can move to the next section.
I was very happy with that attestation information about hardware and firmware. That's very important. That is one thing that we've been struggling here also regarding counterfeit equipment and all of that, especially in the supply chain part. So I think that's a good initiative, attestation information for hardware and firmware.
Thank you, sir. Okay. Thank you, sir. Thanks again. Then let's move to the next section. Chandrakanta, can you display the slide again? Yeah. So next section, we are moving to the next part of the session. The next part is a panel discussion. So I will hand over to my other co-chair, Mr. Krupakaranji. Floor is yours.
Thank you. Thank you, sir. Hope I'm audible.
Yeah, so a bit louder, sir, should be.
Yeah, hope I'm audible right now.
Yes, sir.
Yeah, so it's my pleasure to welcome you all to this panel discussion on security, privacy, and trust in 6G as part of the TSDSI Technical Deep Dive 2026. On behalf of my co-chair, Mr. Saurav from Nokia, and the organizing committee, I extend a warm welcome to all the distinguished speakers, panelists, delegates, and participants joining us today. Over the last few sessions, we have heard insightful technical presentations from experts representing industry, academia, government, and standard organizations. Those presentations have provided us with valuable perspectives on the technological advancements that are shaping the future of communication networks. The purpose of this panel discussion is slightly different. Rather than revisiting these presentations, our goal is to bring together diverse viewpoints and engage in a broader conversation about the future of security and trustworthy 6G systems. We will explore where we stand today, the challenges that lie ahead, the gaps that still need to be addressed, and how industry, academia, government, and standard bodies can collectively contribute towards building a secure, privacy-preserving, and trustworthy 6G ecosystems. I encourage our panelists to share not only their technical insights, but also their vision for the future. And I hope this discussion will stimulate meaningful dialogue that contributes to India's growing role in global 6G standardization. If we look back at the evolution of mobile communications, every generation has fundamentally changed the way people communicate and interact with technology. The second generation, or 2G we say, brought us digital voice communication. The third generation enabled mobile internet access. Fourth generation transformed broadband connectivity and paved the way for the smartphone revolution. The fifth generation connected billions of devices through massive IoT, ultra reliable low latency communications, and network virtualization. Now, as we move towards the sixth generation, we are entering an entirely different era. 6G is no longer just about faster data rates or lower latency. It is expected to seamlessly integrate communication, sensing, computing, artificial intelligence, satellites, digital twins, robotics, autonomous systems, and immersive applications into a unified intelligent ecosystem. This transformation significantly changes the role of security. In previous generations, security was often considered an additional layer added to the communication system. In 6G, however, security cannot remain an afterthought. It must become a fundamental design principle embedded into every layer of the network architecture from the very beginning. Without robust security, the vision of intelligent and autonomous 6G network simply cannot be realized. One of the defining characteristics of 6G is that the network itself is expected to become intelligent and autonomous. Unlike previous generations, future 6G networks are envisioned to be AI native, cloud native, SDR, meaning software defined, highly distributed, and capable of autonomous decision making. They will operate across multiple domains, integrate industrial and non-terrestrial networks, and involve equipment and services from multiple vendors. While these capabilities provide tremendous flexibility and efficiency, they also introduce an unprecedented level of complexity. Every additional interface, every intelligent software component, every AI model, and every distributed computing node potentially becomes another point of vulnerability. As networks become more dynamic and decentralized, the attack surface expands dramatically. This means that conventional security approaches, which primarily focused on protecting network boundaries, may no longer be sufficient. Future security solutions will need to be adaptive, intelligent, predictive, and capable of responding to threats in real time. Where we, where we discuss future communication systems, three closely related concepts consistently emerge, that is, security, privacy, and trust. Security is concerned with protecting the network infrastructure, communication channels, and system resources against cyber threats and unauthorized access. Privacy focuses on protecting users and ensuring that personal information, behavioral data, location information, and sensitive application data remain confidential and under appropriate control. Trust, however, extends beyond both security and privacy. It addresses a much broader question: can we rely on every component of the ecosystem to behave as expected? Can we trust the artificial intelligence models making autonomous decisions? Can we trust connected devices and sensors? Can we trust applications operating across different administrative domains? Can we trust autonomous software agents interacting with one another without human intervention? These questions demonstrate that trust is becoming a foundational requirement for future intelligent networks. Security alone is no longer enough. We must design systems that are not only secure but also transparent, accountable, explainable, and trustworthy. The evolution toward intelligent 6G networks also brings with it a new generation of security challenges. AI introduces concerns such as adversarial machine learning, model poisoning, data manipulation, and autonomous cyber attacks. Deepfake technologies can undermine digital identity and trust. Quantum computing has the potential to break many of today's widely deployed cryptographic algorithms, forcing us to rethink long term security strategies. At the same time, technologies such as network slicing, edge computing, semantic communications, digital twins, and non terrestrial networks significantly increase the complexity of securing future communication infrastructures. The challenge before us is therefore not only to protect larger and more complex networks, but also to ensure that these network, networks remain resilient, adaptive, privacy preserving, and trustworthy in the presence of evolving cyber threats. While technological innovation drives the deployment of new capabilities, standards ensure that these innovations can be deployed at scale, interoperate across vendors, and be adopted globally. Organizations such as TSDSI, 3GPP, ITU, BIS, IETF, and several other standards deployment organizations play an essential role in defining the technical foundations of future communication systems. Standardization is particularly important for security because cyber threats don't recognize geographical boundaries. Secure global communication requires interoperable standards, common security frameworks, consistent trust models, and internationally accepted best practices. Today's discussion, therefore, aims not only to examine technical challenges but also to identify research gaps, standardization priorities, and opportunities for collaboration among academia, industry, government, and standards bodies. As India continues to strengthen its leadership in 6G research and standardization, forums like this provide an excellent opportunity to exchange ideas and shape future contributions to the global standards ecosystem. Thank you once again for your attention. Before we begin the discussion, it's my pleasure to introduce our distinguished panelists who bring together expertise from academia, standards development organizations, research institutions, and industry. Their collective experience spans network security, artificial intelligence, telecom standards, cyber resilience, and next generation communication systems. I'll briefly introduce each of our panelists. Yeah. Ma'am, can you please go to the next slide? Yeah. So, first panelist, Mr. Anupam Agarwal, is an IT professional with over 2 decades of leadership experience in public policy, ICT standardization, business transformation, and large-scale technology programs. Associated with TCS, he has played a key role in technology strategy and standards initiatives. Yeah, next slide. Second panelist is Dr. K. Saujanya, is currently an assistant professor in the Department of Computer Science and Engineering at Motilal Nehru National Institute of Technology, Allahabad. Third panelist is Professor Manjush K. Hanawal, is a professor in the Department of Industrial Engineering and Operations Research at Indian Institute of Technology, Bombay. Fourth panelist is Dr. N. Subramanian, is the Executive Director of Society for Electronic Transactions and Security, SETS, where he leads research initiatives in cybersecurity, including cryptography, secure computing, hardware security, quantum security, and network security. Thank you all for joining us. Without further delay, let us begin our discussion. So, why is 6G different? Every new generation of mobile communication has introduced new technologies and consequently new security challenges. Since 6G is expected to fundamentally transform the communication ecosystem, I would like to begin by understanding what really makes 6G different. Dr. Saujanya, security has always been an important component of every mobile generation. From your perspective, what fundamentally changes in 6G that makes security and privacy significantly more challenging than in 5G, particularly with emerging capabilities such as integrated sensing and communication?
Good afternoon, everyone. Yes, sir. I think most of the key points have already been covered, such as AI, autonomy, trust, and related aspects. I will therefore present it as follows. That the biggest difference is that 6G is no longer just a communication network. It is now becoming an intelligent digital infrastructure. Unlike previous generations, 6G integrates communication, sensing, AI, edge computing, digital twins, robotics, terrestrial integration, and autonomous system into a single ecosystem. This fundamentally changes the security landscape. In 5G, we primarily secure users, base station, and even network slices. In 6G, we must additionally secure AI models, AI agents, digital twins, edge intelligence, autonomous vehicles, industrial robots, healthcare devices, etc. So the attack surface therefore becomes much larger. Another difference is that AI itself becomes both the defender and the attack target. For example, instead of attacking only network protocols, an attacker may poison an AI model, manipulating sensing information, or inject adversarial inputs into autonomous decision making. Finally, we must prepare for the quantum era. Many infrastructures deployed in the next decade will remain operational even after practical quantum computers become available. Therefore, crypto agility, as mentioned by Narendranath sir and the keynote speaker too also, that Thiru sir, that the post-quantum migration must be incorporated from the design state rather than added later. I often summarize 6G as moving from secure communication to secure intelligence. So,
Thank you, Dr. Saujanya. You highlighted how intelligence itself is becoming an integral part of future networks. That naturally brings us to one of the defining characteristics of 6G, artificial intelligence. Now, let me ask Professor Manjesh, AI is expected to become an integral component of future communication networks. We often hear two complementary phrases. As one of the speakers said before, like AI for security and security for AI. From your perspective, how do we strike the right balance between these two?
Okay, thanks, Kirubakaran. And I also thank all the co-chairs for inviting me for this wonderful workshop. Okay, to begin with, of course, AI is going to be one of the distinguishing features of 6G compared to the other Gs we have seen before. Many applications, many services will be built on top of it. And of course, as everything, any service or applications, security is going to be a concern. Before I jump into answering my perspective on that, I want to revisit some of the point Narendranath ji mentioned about like many of these things could be better handled if we maintain a proper inventory. And he talked about crypto bomb and S bomb. So these are some of the things even we try to take it in 6G requirements, especially in SA1, but somehow looks like there is not much attraction for it. Hopefully, things could be of find more relevance in SA3. So that is one point. Now coming to your point about AI for security and security for AI, right? For me, security of AI is a much larger concern than AI for security, because like security we have been always taking care of through various aspects, and AI is possibly going to just either help us improve our efficiency in handling those securities, but it's not going to like basically we are getting these security issues because of these vulnerabilities and all the way we implement the things or protocol issues. AI itself is not going to create, but maybe whatever the issues we had before, maybe AI will help us to identify them and rectify them faster. Now this brings to me the important factor, like okay, the security of AI for us. Yeah, a lot of discussion is happening already about using AI in the 6G network. Now SA2 is talking about 6G architecture and trying to see that where all AI is going to play a significant role. For example, key issues 18 and key issues 19 are talking about AI for 6G and 6G for AI. And one of the important things I'm seeing is making the core as much of agentic possible. Also, Narendranath ji talked about the issues we face in AI, like a data poisoning and all. Okay, these are all there. But now the moment we move to the agentic scenario, things become even complicated. For example, now we are talking about this AI agent being used for planning, execution, and they have access to tools. Now, the granularity of access, interaction between the various agents, and them collaborating and executing a task, multiple layer of data being exchanged, things suddenly looks a lot complex. Now, what is the framework to address this? When multiple agents to talk this, do you have a framework? Maybe not yet. I mean, these are all fastly emerging area, right? This agentic AI itself has rapidly evolved so fast, maybe in the last couple of years. I feel that that is something we should really look into. And I already see that SA3, some data framework that security need to be addressed in the data framework is already taken up. And I'm sure this is also going to cover about the data being exchanged through various agents. And of course, how they are not only security point of view, privacy point of view, also how they are taken care. So this is my view. I think with the AI coming predominantly in 6G, lot of additional security just because of this is going to come, and we need to think through and start planning a framework for that.
Interesting. Dr. Subramanian, would you like to add the practical and deployment perspective? Dr. Subramaniam Nilakandan sir, you are available.
Manjesh, can you go on mute? Voice is echoing from your side.
Yeah. Thank you. Thank you for the organizers, and nice listening to all the keynote speakers and the panelists who spoke earlier to me. So I think the context about this particular question on two things. One is on the 6G transformation, where we have seen things changing from 5G, which is more on service-based architecture, and things are getting more, softwareized and cloud-enabled, and that gives a good platform for the adoption and opportunities for AI. So taking further what Professor Manjesh said, we see that there are interesting opportunities that the AI catches up on the agentic front and application, plethora of application opportunities that would come. But even beyond that, to the core and the edge aspects with respect to the real-time data management, as well as with respect to overall network and control measurement. So AI has a larger role to play. Now, coming to that of the security, when you look at the attack vectors, then you see vulnerabilities and concerns that would naturally come from the entire infrastructure elements and the edge, like IoTs and the edge kind of concerns with respect to the vulnerabilities that are already there, which are applicable even in the other typical use cases. And then you would have concerns specific to telecom, such as jamming, eavesdropping, and things like that, node compromise attacks and things like that. How AI can really be also useful in modeling and keeping track of these vulnerabilities and being more proactive. How do you look at the anomalies and devise effective measures for it? These are again things that will unwind. Also, there are concerns even at the radio access network level, which needs to be addressed. Now, the other aspect, what I also reflect what Professor Manjesh said, is about the adversarial attacks. So you see larger concerns more from whether it is inference perturbation kind of attacks that AI opens it up, or evasion attack, or model extraction inference attacks and things like that. These are going to be really concerning, but it is nice to see and hear from one of the keynote speakers who highlighted about the new initiative about the AI Proto that talks about discussions at the standards level to see how this governance structure can be looked at from a 6G communication perspective. So I think when you look at overall AI governance perspective, you have various risk management framework that are coming up, and we need to see how such governance framework are applicable and adaptable in the context of telecom infrastructures. And we need to see how we handle the model risks and the operational risks once you roll it out and see how things change. And of course, there are ethical and regulatory kind of concerns. So I think I see more like there are interesting opportunities to look at it from more network operations and management, leveraging AI to become more proactive. And the caution that I agree with what the others spoke about, to take care of effective measures to see how adversarial attacks and concerns of AI can also be handled over here. So this is my view with respect to the converging areas of AI and cybersecurity in the context of 6G. And just one more aspect, when we talk about overall context of 6G, it also talks about the non-terrestrial networks coming into picture. So one needs to see how we look at that planning out. Yeah, thank you, Krupa.
Yes. So one more question on it. If attackers are increasingly using AI, do you believe defenders should also rely on autonomous AI-driven defense mechanism?
Yeah, so that's what I said. So there are interesting opportunities to definitely see how AI can be useful for proactive security. So when you talk about the edge security and the application level agentic concerns that are going to come, it is well possible to devise proactive, interesting anomaly detection capabilities and proactive vulnerability automating capabilities and things like that. Yeah.
Thank you, sir. Thank you, sir. Then AI learns from data, and future 6G applications will continuously generate enormous volumes of highly sensitive data, which naturally raises another important question called privacy. Dr. Saujanya, applications such as extended reality, digital twins, connected healthcare, and autonomous transportation continuously collect user information. How should privacy evolve beyond today's mechanisms?
Yes, sir. So, see, today's privacy mechanism largely focus on protecting data during storage and transmission. However, 6G applications continuously generate contextual information such as location, body movements, biometric information, emotions, health records. So, protecting only the communication channel is therefore insufficient. So, privacy must evolve into privacy by design. I believe future 6G networks should incorporate 5 principles. The first one is data minimization, of course, that collects only the information necessary for the service. The second one, I must say, decentralized processing using edge intelligence. Sensitive information should remain close to the user rather than always being transmitted to the cloud. The third one is AI-assisted privacy enforcement that continuously monitors policy compliance. Fourth, privacy-preserving machine learning using techniques such as federated learning, differential privacy, and secure multi-party computation. Finally, the cryptographic innovations such as homomorphic encryption and post-quantum secure encryption will enable confidential processing even in untrusted environments. So in short, privacy should become an intelligent and adaptive network function rather than merely a regulatory requirement.
Thank you. Dr. Subramanian, from an implementation and standards perspective, how do you see privacy evolving?
Yeah, so one aspect of privacy we have seen in the 5G that was not there probably earlier is with respect to the security of the international mobile subscriber identity, right? Through SUPI and SUKI concealment of those identifiers. So these are fundamentally ingrained in the way the UE communicates and reveals the information about subscriber. So I think that is one thing we are already seeing in action. Now, of course, this leverages quite a lot of crypto primitives, which are asymmetric cryptography, and it needs to go to a post-quantum scheme. So that's a different topic of discussion. But then we already see the concerns of privacy being addressed since 5G rollout has started. Now, the aspect, as rightly pointed out by the fellow panelists, is interesting to see the plethora of newer environmental detail and revealing of information about the users and their environment is kind of concerning more from the application perspective and sensors data collection perspective. So that is where I do agree that the advancement that you see in what is the privacy enhancing techniques, the crypto schemes, which talks about how do you treat this data collection point itself, and then differential privacy, adding certain noise, and then trying to transform the data, but then securing the privacy of it. Similarly, various schemes have been talked about. Again, coupled with the AI for federated learning environment, we need to see how these things are going to get adopted in the entire scheme of standardization initiative. So when you talk about the, again, I look forward again to the same one, the agent, the AI Proto working group, even talking about the agentic framework, data collection will start coming, and then how schemes can be inbuilt to adopt some of these privacy enhancing schemes so that it becomes very inherent when the data is getting collected and getting processed, when it is getting transmitted between entities against different jurisdiction. Yeah.
Thank you, sir. We could see different aspects in data collection point, but in the same way, let me put the same question like in a different way. Like, do you think users should ultimately own their data, or should network operators remain responsible for enforcing privacy?
No, I think it will be definitely the service providers, not only network service providers. We do see that the ecosystem may change with multiple players coming into picture. The content providers will be there, application service providers will be there. So there will be jurisdiction of privacy that will what you call the data processing owners would be responsible, depending on the kind of data collection and the ownership of data, what they do it. So so I think it's a multi-jurisdictional thing, and there will be responsibilities at multiple levels.
Interesting, sir. Thank you. Thank you so much. So far, we have discussed protecting networks and protecting users, but future networks also require something more fundamental, that is called trust. So trust has become one of the defining concepts of 6G. Beyond authentication and encryption, how do we establish trust among devices, AI agents, applications, and multiple administrative domains? Let me call upon Mr. Anupam from TCS. Could you please comment on this one?
Thanks for inviting me in. It was lovely hearing all of my fellow panelists. So from the standpoint of trust, let me give you a very simple example. Okay, my son trusts me, but am I trustworthy? So the question is not about giving the trust. The question more is about being what we need works are actually trustworthy in nature, and that is the real problem. And to start the conversation, I'll say that it was all said in the first slide which Saurav projected, wherein he mapped various different standardization bodies working on different parts of very clearly trust was something which was not getting highlighted there. Okay, but if you look at some of the other SDOs like ISO and IEC, that is the place where this trust is actually getting worked upon. So trustworthiness of AI systems, I think that is something which is extremely important, and it is not happening in the regular telecom SDOs. It is happening outside that, and it is very important that we start looking into it. Now, to further the point which I am trying to make that while 3GPP is introducing the AI capabilities into the network function, okay, ITUT is working on the AI and autonomous networks, which is fine. But it is the ISO JTC1 SC42 which is working on AI governance and trustworthiness standards. So there is a collaboration which is required between this different SDOs, and that is the place we need to work on while we are standardizing AI enabled networks, but we still lack the standards for assuring that AI itself. And that is the place to work upon to ensure that trustworthiness is there in the ecosystem.
Okay. Okay. Thank you, sir. Professor Manjesh, could you please comment on the same line?
Yeah, I am not an that much expert on the privacy and the trust part, but yeah, I just want to comment that privacy, it's all about like declaring what is that, how the data that we are going to generate that is going to be used in the system. I think 3GPP is already considering various consent aspects here, like what I give to the system, and I will also consent like how my data that I'm going to give to the system is going to be used. As long as we can make it very transparent to the user, I feel trust will be already part of it. And already there is a lot of for operators, maybe it becomes a big issue, like how to seek the consent from the users, and at what granularity they are going to collect the data, and how they are going to store and manage it, and to which third-party applications they are going to expose this data. So these are all concerns. So but as long as these things are clearly informed to the user, hey, I'm going to collect this data from you, but this data, I'm only going to use it for this purpose, nothing beyond that. And if I restrict myself to only that kind of utility of that data, I feel trust will also be there. I feel the proper consent management will precede the trust. If the consent is appropriately handled, I feel trust will naturally be there in the system.
Thank you, sir. Once again, Mr. Anupam, from the perspective of BIS and other standards development organizations such as TSDSI, 3GPP.
Manjesh, you have to go for mute. There's some echo is, I don't know, sometimes. Yeah. Thanks.
So let me repeat, Mr. Anupam, from the perspective of BIS and other SDOs such as TSDSI, 3GPP, ITUT, and ITF, what do you see as the biggest standardization gaps that still need attention?
So, I don't see that there is a lack of standards, which is the gap, but it is the proliferation of the standards which are getting developed in silos. And that is what I said earlier also. Because 6G is not going to depend just only on the telecom standards. It is also going to depend on AI standards. It is going to depend on cybersecurity standards, software engineering standards, cloud standards, digital twin standards. Okay. So the real challenge is that how do we ensure that all these standards work coherently? So let me give you an example. If 6G is going to be used in a future smart city, and there is a smart city disaster response which needs to be done, then the entire system of telecoms, hospital management, road networks, everything needs to work together to ensure that the disaster is managed very well. So, and there are going to be standards for each one of them. So how do we start seeing systems not just as a telecom system, not just as a hospital system or road system, but the entire idea of systems and interoperability between the system of systems? That is a place where I feel standardization community needs to start working upon.
Okay. One of those emerging technologies that is already influencing standards discussion is quantum computing. Let me ask Professor Manjesh, quantum computing has the potential to disrupt today's cryptographic foundations. How should 6G prepare for the transition toward quantum safe security?
Okay. Say 6G is kind of coinciding with the AI revolution and the quantum era, right? 6G maybe just started last year, and that is when the major jump in AI is happening in terms of the agentic framework and all. But thankfully, the quantum thing has come much earlier, and I see that a lot of standardization activities are already happened on the quantum side compared to the agentic framework and the regulations that have put on the standardization aspects on AI. The quantum things looks much ahead. We already know that NIST has already standardized many post-quantum algorithms, and now their deployable versions are available. People are already deploying them and testing them. So since standards are already available, I think Thiru talked quite a bit about that from the IETF perspective. I think we should go ahead and use them. And as Rajvel mentioned, the migration plans are already discussed. And I personally, this is my personal opinion, again, like Nokia, we feel that the hybrid version should be something we should go for, so that we have the guarantee from both the worlds, like whatever we trusted so far in the classical world, that continues, and whatever the future threats we are going to see from the quantum computers against which we are well defended of. I feel that and also like we ourselves have implemented them. Implementing them and migrating them is not a big issue. Like as I said, TL, OKS libraries have all made this standardized algorithms already available. We can simply incorporate them in our maybe enable our browser to use it, or in the telecom, whatever the mutual TLS we are going to use it, enable it, use it in IPsec, everywhere we can bring it. And I feel that since the standard post-quantum algorithms are already available and the mechanism already available to incorporate them, we should quickly migrate as soon as possible. And I think a good progress has been already made on that. So nothing much to add. Things are on track there.
Thank you, sir. Dr. Subramanian, could you please comment on the same?
Yeah, so I think basically when you look at this role of cryptography, nicely covered by both all the keynote speakers, bringing out various task force discussion at 3GPP at IETF level. You see the application of cryptographic schemes, whether it is symmetric key cryptography or asymmetric key cryptography, spreading across layers of telecom infrastructure. So, for example, when you talk about the UE to base station, right? And then when you talk, that's where about your subscriber identity and authentication. Then you talk about from the base station to the core, right? And then you talk about the SBA kind of an architecture within the core, network core itself, and then the communication and crypto schemes that are going to be used over there. Leaving all that, again, the communication that would happen between inter-telecom operators and things like that. So you see a lot of crypto elements that's already gone into all this place. So there is a huge amount of kind of cryptography that is kind of getting implemented in the 5G itself. Now, when you talk about post-quantum scheme, then rightly, as again the earlier speakers have highlighted, one of the important things that are being discussed in the standards formulation level is about the visibility and knowledge about the crypto assets that are there. So that is anyway, there are guidelines to naturally do about it. And rightly as said by Professor Manjesh, these are there are specific standards that are already published, and we need to adopt it. For that, you need to know what are those crypto elements that needs to be changed. Again, there was a discussion and suggestion that maybe you can strengthen the current AES, though it is not per se challenged by the quantum threat. But for the other aspects like TLS or IKE in the IPsec and wherever these things are getting used, which are public key crypto systems, then obviously you need to look for a migration. And again, the proposal that came very clearly looks like adoption of hybrid chem. So I think this would evolve, and this is to be done in a rapid way. The only challenge, as again Sri Narendranath highlighted, is basically on the agility, crypto agility aspect of it, because these crypto algorithms are getting standardized these days in a very rapid manner. Not in it doesn't take a decade now, right? So it happens very fastly. So you need to see how do you have those systems and hardware and things in place where you would be able to quickly change or migrate. So I think those are challenges, number one. Number two is when you talk about 6G kind of telecom infrastructure, when you adopt these standard schemes, you need to be aware of the performance and the latency implications to because at one end we talk about 6G to adopt quite a lot of low latency services and things like that. So you need to see how this is panning out. But then I think these are going to be interesting things that for the next 2 to 3 years, I see that this would be very interesting to migrate and adopt across the various layers of telecom and application ecosystem.
Thank you, sir. Let me ask Dr. Saujanya, should operators initially deploy post-quantum cryptography, or do you also see a future role for quantum key distribution in telecom networks?
Yes, sir. I believe that the answer is not either or, but both, that used appropriately. The post-quantum cryptography is software-based, cost-effective, scalable, and suitable for almost every network element. Therefore, it should become the primary migration strategy rather than Quantum key distribution offers information theoretic security, but it requires dedicated optical infrastructure, specialized hardware, and has deployment limitations. So hence, QKD will likely complement rather than replace PQC. So I envisioned a layer architecture where PQC secures the general communication, hybrid cryptography supports the migration, QKD of course protects extremely sensitive backbone links, and crypto agility allows future upgrades. So this layer, the approach provides both scalability and long-term security.
Okay, thank you. Thank you for your valuable comment. And so far we have discussed preventing attacks, but perhaps the bigger question is what happens after an attack occurs? Once again, I ask Dr. Subramaniam, future networks cannot simply aim to prevent attacks. They must continue operating despite attacks. How do we build resilient and self-healing 6G networks?
I think that's a very tough question because this keeps evolving, right? Because self-healing is a very powerful terminology. So basically, of course, to some extent, one can be aware of putting in proactive elements into picture to keep knowing what are the changing vulnerabilities. But then, how are you going to handle 0 days and unknown vulnerabilities and things like that are going to be a challenging thing. So I feel that definitely anomaly detection models, effective methods for adoption of AI for network control management and things like that would lead towards such a proactive approach as a step towards it.
Okay, thank you, sir. Then, Professor Manjesh, would you like to comment on this line?
Yeah, about resiliency of the networks, right? Like,
yes, sir. Yes, sir.
I would.
Okay.
Yes, sir. So, I don't also have clear. See, there are when we talk about network being resilient, right? That means you have to provision lot of resources, right? Anything kind of emergency situation comes, network should be able to handle those things. But this becomes a game of what is the resource you are provisioning and what is the extreme conditions you are getting yourself ready. So that's a quite of investments, right? And it could be it can't be coming at a very low cost thing. So that is where I feel the trade-offs comes into picture. Yeah, we have to prepare for the worst scenarios, but at what cost? And telecom operations has to take into account, like if I have to be working under all operations, what kind of provisioning that has to be done. But of course, there will be some resistance here from many fronts here. But what I want to highlight from the security point of view is, yeah, one is the resiliency things will come into picture because your network is overloaded and maybe that's nothing related to the security. But it could be resilient. It has to be again on the security also, because even though it's not because of the load factor, it is just that somebody can bring down the network and test its resiliency because of the security issue. That is where I want to connect you to another point that Narendra Naji pointed out about the monitoring of the network for various activity that's happening. If we can proactively maintain the network so that any such bad security incidents taking down the network can significantly be reduced. And as you saw, I'm very happy to see that in SA3 now there is in the study, there is already a security event collection. That task is already taken up. And earlier, this task of monitoring the security was outside the 3GPP purview. Maybe there used to be a separate setup which used to collect the necessary events and monitor the security all the time so that the network is up and running securely all the time. But now that aspect is now maybe part of the trusted domain itself, where you actually start collecting the right events from the security monitoring point of view and make sure that identify any potential causes proactively right before that happens. I feel that this can be one of the important directions to make the networks more resilient. And I see that the networks are already going ahead in that, instead of relegating this task to some third party or considering it as an outsider trusted domain aspect. That's all I can think of at this time. Thank you.
Yeah, Kiru, I can jump in here.
Yes, it is.
Yes, it is. Please.
So very clearly what Manjesh has said and what Naren Naji has also mentioned, that we just cannot continue to look at network from the security standpoint. One of the perspectives which was brought in of network monitoring, or we can also say that network performance. Similarly, there was also a mention of the network architecture itself. Okay. So resilience will not come by improving the security posture. Resilience will come by doing certain different things right and doing those right things continuously. So we will have to look at the network architecture. We will have to look how network operations are managed. Network security is definitely the key thing. But apart from that, we need to look at what is the network performance, what is the network observability or visibility, how the users are able to see the network from outside, or how the operator themselves are able to see the network. And finally, what are the compliance and the governance dimensions of it. So I'm happy to share that all these different dimensions are actually now part of a standard which is getting developed in BIS called Network Maturity Assessment Model. And these have been included there as some of the practices. And these practices are then being elaborated in the context of what is the expected outcomes. So if the learned members of this panel and the participants, they can look at this BIS standard on network maturity assessment model. I think that gives a very fair idea of creating the network resilience and how should a network be functioning at the time of disaster, as well as trying to protect itself when there is an attack.
Yes, sir. Thank you, sir. Actually, I was about to ask from your side this question, like you have been actively working on the network maturity assessment model under BIS. Do you see NMAM evolving into a benchmark for assessing 6G readiness?
I missed your question, Kiru, possibly because of the network bandwidth.
No. Actually, do you see network maturity assessment model evolving into a benchmark for assessing 6G readiness?
It can definitely be used in that context. Though the original idea was to write it from the standpoint of enterprise networks. But in the context of 6G networks, I think that can be considered as a good management standard to see that how the network is evolving.
Okay. Thank you, sir. And thank you. That has been a fascinating discussion. Before we conclude, I would like to move into a quick rapid fire round. I would request each panelist to keep their answer to about 30 seconds. Let me go with Dr. Saujanya. If you had to identify one research problem that every PhD student should work on in 6G security, what would it be?
If I had to choose only one problem, then it would be building trustworthy AI native security architectures that remain secure even in the post-quantum era. So today's security mechanisms largely assume static environments. However, 6G will be autonomous, that is AI-driven, distributed. So the grand challenge is therefore, how do we build networks that can automatically detect threats, explain their decision, that is explainable AI, adapt to new attacks, preserve privacy, and remain quantum safe or without human intervention. This is the single problem, sir.
Okay. Thank you, ma'am. Mr. Anupam, what should be India's highest priority in security standardization over the next 3 years?
Okay. I think the highest priority should be standards for assurance of the autonomous digital systems, because AI will be increasingly making decisions in telecom networks, critical infrastructure, transportation, healthcare. So the challenge will no longer simply be securing the networks. It is assuring that the autonomous systems behaves and operates reliably and transparently. So that is going to be the key priority for the standardization.
Okay, thank you, sir. Then Professor Manjesh, what is the biggest misconception surrounding AI security today?
Okay. I mean, we have heard about recently about Mythos and Fable, right? They are identifying a lot of security issue, and everybody is saying that, okay, AI is now going to attack my networks and bring down. I feel that is where we need to understand and understand this from better perspective. What Mythos and Fable or any other cybersecurity tool is trying to do is like identify what vulnerabilities are there in a much faster way, which otherwise would have taken a lot of time for us. In that way, AI tools are not solving our security problems, but what they're trying to do is help us identify the issues quickly, which we have taken a lot of time writing test scripts, some test cases, following that standard procedure. But what I feel that more important from is, yes, AI is going to play a dominant role. Yeah, we need to worry about what are the new security angles that it is going to bring, especially when we are going to use it for a lot of automation. Yeah, I think our focus should be more on seeing that what are the new additional security landscape that AI brings, rather than like having the misconception that somehow AI will solve our all the security issues. Thank you.
Yeah, thank you, sir.
Thank you,
Dr.
sir.
Subramaniam, what single technology will have the greatest impact on telecom security by 2030?
Yeah, I think going by all the global timelines and things like that, right now everyone is running fast on the quantum resiliency, though it is more of an adoption. But for telecom, I think it is to do with performance balancing and things like that. And yeah, I think otherwise all other things are also equally important, like looking at AI and all that stuff. But I think cryptography has been nicely implemented in 5G. That will go to a greater scale with privacy and quantum resiliency. Thank you.
Thank you, sir. Thank you. Before we close, I would like to ask each of you one final question. Please answer as in a brief. If TSDSI were to prioritize just 3 work items over the next 12 to 24 months, what should those priorities be to strengthen India's contribution to global 6G security and privacy standards? So let me start with Dr. Saujanya.
Yes, sir. So the TSDSI, so develop an Indian 6G, of course, 6G post-quantum migration framework and standardized trust frameworks for AI native networks. And the third one is you have to establish security and privacy standards for emerging 6G applications like digital twins, Industry 5.0, connected mobility, etc. So these are the three.
Okay, thank you, ma'am. Then Mr. Anupam, what did you say?
No, I'll say that I think there is enough standardization work which is happening, but those are happening in silos. So, and we have got experts working in different standardization bodies, whether it is in 3GPP, whether it is in 1M2M, whether it is in ITU. So I think rather than picking up a topic, my take is that we need something like a standardization task force for 6G, wherein as a country we can have one coherent voice, because if we are participating in IETF, we are participating in 3GPP, we are participating in other places. What is the national level agenda on the 6G? If that is something which is clear in terms of standardization, it will be much easier to navigate through the standardization landscape, and the issues can be taken care of thereby. Thank you.
Okay. Then Professor Manjesh.
Yeah, from my point of view, 6G, as we know, is already going to come with a plethora of good support for new applications, but this will only going to increase the security landscape and threat surface. But for me, one thing we should look for is how to have a good visibility in my network so that I can preempt any such kind of security attack by proactively monitoring. And I definitely resonate what Narendra Nathji said, like we should have some kind of policy that, okay, there should be some kind of bill of material properly listed and clearly define, hey, these are the security events I need to definitely monitor, so that any security breach happens, I should be able to pinpoint, or as a preemptive methods, to implement any preemptive methods, I need to know these security events, so that if there is anything abnormal going on, I can prevent it before any bad thing happens. So visibility, bringing in good network visibility, I feel that one of the something important factor from the security we should look in 6G.
Okay, thank you, sir.
Thank you, sir.
Then Dr. Subramanian, from your side.
Yeah. So I think I agree with your panelists to say that we need to converge with the international standards. But I think also we see a lot of innovation happening in the country, trusted ecosystem as well as post-quantum cryptography, as well as in the area of attestation we talked about as a bit. I think these are somehow things
So sorry to interrupt you, sir. Mr. Manjesh.
Yeah.
Can you go on?
Yeah, so I think there are enough opportunities that we can create for the new startup ecosystem by having standardization aligned in these activities. Like, I see a huge opportunity in rolling out next 2 to 3 years on the post-quantum schemes as well as on the attestation services, because we talk about cloud and containerization and all that stuff. So I think those are some of those things we may have to quickly do it in TSDSA. Thank you.
Okay, thank you, sir. Thank you. And before we conclude, there are some questions, very few questions from the audience. Let me read, and who is commenting or who is answering, please come forward and answer. For the 6G network to be secured and trusted, network equipment from trusted source has to be procured. In geopolitical context, government may prohibit buying such equipment from certain countries. Will this not affect competition and affordability?
I'm sorry, where are these questions put? They are in the chat box?
Yes, sir. In the right-hand side, Q&A separate option is there.
Yeah, we see that. Yeah.
Yes.
No, I think trust is, I think as we talk about those, there are inherent mechanism of trust that are getting more and more through hardware root of trust and things like that coming up, right? So, but of course, this is a tricky question because it talks about even the, geopolitical context and the hardware thing. But I think we are catching up on to two things. One is that 5G is actually moving more from the softwareized ecosystem as well. So we have a larger opportunity there.
May I come in? If you don't mind, not in the panel, but
yes, sir. Please, sir.
Please.
I think he's talking about competition and cost. Yeah, they're important components, but I think considering that telecom is such a critical infrastructure, if something happens to their network, that viability of a nation to function is affected. So that's where I think from the national security perspective, when you take an assessment and say that some certain vendors are not to be trusted, I think that has to be taken in practice, and that is applicable across all service providers. It's not that a particular service provider is affected because he can't make a procurement decision on that. It's applicable across all service providers. So that's a considered decision that's taken, keeping in mind competition and the cost implications. But I think where national security has higher costs, just imagine what happens when networks are down. The costs are very high. So I think that's where the considerations come when those decisions are taken.
Yes, sir. Thank you, sir. And also, one other participant has commented, zero trust architecture is also there. Yes, that is true. And how do you see network slice security evolving as we move forward, meaning move towards 6G?
Yes, sir. I think network slicing in 6G will move beyond simple isolation. In 5G, we primarily focus on creating separate logical networks for different services. In 6G, every slice will need its own security intelligence. For example, a slice supporting remote surgery will have very different security requirements from one supporting video streaming. So security policies, authentication, encryption, and even AI-based threat detection will have to be tailored dynamically to each slice. And I also believe zero trust and post-quantum cryptography will become integral to slice security because 6G networks will support critical infrastructure and remain operational for many years. So rather than thinking of a network slice as a just an isolated partition, I see it becoming an autonomous, adaptive, and continuously protected security domain.
Thank you, ma'am. Hope all questions are answered. I think all participants who are happy with the answers by our panelists. And once again, thank you to all our distinguished panelists for sharing your valuable insights, and thank you to the audience for your participation. Today's discussion clearly demonstrates that security, privacy, and trust are no longer optional features. They are foundational design principles for future 6G networks. We have explored challenges ranging from AI native security and privacy to trust, quantum safe communications, resilience, and standardization. More importantly, we have identified opportunities for India to contribute meaningfully to the global 6G standards ecosystem through collaboration among academia, industry, government, and standard bodies. On behalf of TSDSI, I thank our panelists, the organizing team, and all participants. I hope today's discussion inspires continued collaboration and concrete actions toward building secure, resilient, and trustworthy 6G networks. Thank you, and enjoy the rest of the technical deep dive. Mr. Saurav, I'm handing over to you.
Thank you, Gurbakanji. So thanks a lot for organizing all the panelists and you for organizing such a nice discussion. I'll quickly conclude the whole session, right? So today's session, we highlighted the 6G security cannot be addressed by single standards body and a stakeholder. It requires coordination among the ecosystems. And there we started 3GPP, where 3GPP perspective demonstrated how the security is being embedded into the mobile system architecture, while ITF perspective highlight how important and secure interoperable internet protocol should be, right? While ITF and the national security perspective, Mr. Nail Naji, which highlighted, right, remind us communication network are now critical national infrastructure and making resilient and trust strategic priorities in 6G design should consider these national security aspect as well, right? This is the main thing with what we have observed in the first half of the session. The second half, the takeaway from the panel discussion, as Kurbakaran just very well highlighted and summarized it, right? The panel discussion that, okay, mainly the aspect what we discuss is security, privacy, and trust must be built into the 6G from day one. It's not like after the thought, we have to integrate all this security privacy from day one and then integrate into the design. Now, I would say journey to 6G has already started, and the decision we make today will shape a security foundation of next decade. With this, I would like to conclude the technical discussions. Thanks a lot. Abhishek Chandrakanta?
Yes, sir. So I request everybody to kindly turn on your video to capture a photograph.
Chandrakanta? Yeah. At least I cannot hear you, Chandrakanta.
Hello.
Yeah, maybe you can, for the feedback, right? You want to?
Yes. So thank you, sir, for your inspiring concluding remarks. And before we close, we kindly request all participants to share their valuable feedback on today's session. And your feedback is extremely important to us and will help us further enhance future edition of the TTDD conference. You may submit your feedback by clicking on the feedback link shared in the chat window or simply scanning the QR code displayed on your screen.
Thank you. Thank you all again.
Thank you.
We warmly invite you to join us in next session at 4:30 p.m. IST, entitled HAPS-based connectivity, technical feasibility trials and market dynamics. Have a wonderful conference experience, and we look forward to your continued participation. Thank you.
Thank you, ma'am.